Okay. Welcome, everyone. And usually I like to start some of these technical presentations. I actually have a slide that says, welcome to French Literature Introduction, so people freak out, not in the right class type thing. So my name is Bryan Cafferky. I work for Microsoft, and I work on the data science. I've been in technical sales. I'm in data science, so I usually just call myself a data science and AI enabler because it kind of covers whatever I'm doing at that point. And please reach out on LinkedIn. If you can put a message saying you saw my riveting presentation and you loved it, that's even better. Then I know why you're reaching out, because it kind of helps to have people know where they're coming from. All the content, slides, notebooks, I put them in a DBC, the Databricks compressed format. They're available on GitHub. I know they'll make them available here, but I like to put everything on GitHub. So github.com/bcafferky/shared. I got a ton of stuff out there for my YouTube videos as well. But if you look under the Spark and AI Summit 2019, you'll find this stuff as well. So. And by the way, if you get a chance and do connect on LinkedIn, please take a picture so I can prove to my dad I actually spoke here, because he won't believe it. So if I show him a picture, I can't take one. I also have a YouTube channel. So I do a lot of videos and things. So I like to always promote my channel, get more subscribers, but it's just for fun. I like to do it. I get really excited about this stuff, and I love to share it. So kind of where are we going in this discussion? We will be taking a break. So this is 2 parts. I'll probably break on the SparkR kind of things. I'm going to be talking about SparkR first and SparkR, and I'll do kind of an overview of both. But I want to give you kind of a R on Spark conceptual overview, key considerations and things to talk about there. SparkR versus SparkR, code demos, which is what people love. Has anybody here used Databricks? That's a good start. And how many people here, I take it, use R? Does anybody also use Python? Okay, good mix. And has anyone used SparkR? Okay. And then SparkR? Okay. So it is not a deep dive in the sense I'm going to get into the binary code and start walking through it as much as conceptually how to use it and some advice about how to leverage the two and also interoperate with them. So we'll kind of go with there, and then we'll wrap up. So I like to get excited about this stuff. And when I started in computers, I know this really dates me. You're probably thinking I look like I'm in my 20s. But really, I go back a little ways. So this was my first real computer. I was really excited about this. I had to save up my first job money to buy it. And I would come home from work, really, and do this all night. And then on weekends, Friday nights was great. You could have a 6-pack of beer and work on my Atari computer. So this was great because it was a really cool architecture. It actually had 3 different graphics chips to help it with its graphics, including a player missiles chip that, unlike sprites, it physically had hardware that moved things around and detected collisions and everything. And it had a separate sound chip, and it was really cool. And I had a floppy drive. So I go back so far that most people still had cassette recorders to record their programs with, which was quite painful. So floppy drive was like, wow, random access storage. That was amazing. And my programs. So if people remember the Commodore 64, right? So the Commodore 64 is to Atari. Commodore 64 is like the Yankees. And I come from Boston, so this is an analogy. And the Atari is kind of like Boston Red Sox. You know, it's always struggling to keep up, but it doesn't have the deeper pockets, and that's kind of how Atari always was, but always kind of a competitive in a friendly way with the Commodore. So the point of all this, so also I had to go out then and get the Atari Computer Guide, a book on writing player missile graphics, and this was my goal, to write games like this. So that's how I started in this. And the point of it is, this is supposed to be fun, right? We're supposed to enjoy it. I personally have found at points in my career where I stopped having fun because maybe there's too much pressure, there's too many deadlines, or there's too much politics. But I find it's really useful to remember, this is fun, this is really cool stuff. And when we're talking about this stuff, Spark is one of the coolest things I've come across in a long time. I really get excited about. And Databricks just makes it that much better because I'm really lazy, but I will work night and day to find a better way to be lazy. So I like Databricks because that's what it lets me do. I don't have to worry about configuring. I don't have to worry about setting things up. But Spark is still Spark, and we'll see that Databricks is really a wrapper around Spark. So a couple of things for people here. Everything I will cover applies to Spark in general. It's not really specific to Databricks other than some flourishes you can do with Databricks, but you can do everything with Spark. A couple of little maybe access point, little differences, but overall it works. And that's really good because documentation-wise, Databricks cannot document everything in Spark. Spark Online documentation covers it nice, so you can do PySpark if you want Python, R, SparkR, and SparkR has good documentation you can go, and it will work with what I'm talking about here. So kind of going back to the basic architecture of Spark, and what I want to sort of focus on here is the sort of idea, so you've got this core engine, right? And one of the things I really liked about Spark when I first saw it is that it supports SQL out of the box. So I'm kind of come back from a relational database background, and I like SQL. I think it's a very rich expression language for data wrangling and querying. And so that Spark supports out of the box is great. One of the reasons that they added that is because by knowing what you're trying to do with the SQL language, it can be optimized. And so Spark is able to performance tune, basically, very similar to the way relational databases work, your queries. The interesting thing is we're going to see that R and Python leverage that ability so that when you get data frames, you're also getting that ability to have better performance. You also have scaling out machine learning library called MLlib, or MLlib, depending on how you want to pronounce it. And so that allows you to not only do data wrangling at scale, but you can also do machine learning at scale. And then you've got a streaming engine and graph API and things like that. So a lot of cool stuff, and you have the flexibility of using the resource manager under the covers that you want. And what's nice also with Spark is, of course, you get that interactive or batch mode kind of thing. So I tried to get into Hadoop when Hadoop came out. And honestly, I just found it too tedious, and I didn't like writing in Java and writing MapReduce. So I am lazy, but once I saw something like Databricks or Spark, I'm like, now I can do this. So one of the key things to recognize from the diagram is there is no direct support for any languages other than SQL, Scala, and Java. And then Databricks adds some extra flourishes for the operating system. But that's it. So when you want to do any programming with something like R, you need to have a wrapper around it. So we have SparkR and SparkR, which are really just wrappers around the Spark API and let us do things. The idea is, and I'm going to try to coin a new phrase. Maybe I'll be the one to start this. In Python, they call everything Pythonic. So I'm going to call things orthonic. And maybe they'll catch on. And then I'll be the one that started. It'll be here when it happens. And I think really when you talk about SparkR in particular, I think I would call it sort of orthonic. And then so we'll see that a little bit. That's actually going to, kind of like the evening news, though. I'm probably not going to get too into that until the next part of my presentation. We'll have a short break, get a drink or whatever, come back, and we'll cover the rest of it. So when you're talking about what Databricks is, I couldn't find anything expressed it well, so I just put this together myself. If you think of Spark as the core engine, Databricks is just this user-friendly wrapper around it. It's really nothing more than a really nice GUI with a portal, click and drag and do things on it, and it gives you a lot of tools, but at the end of the day, underneath the covers, it's just Spark. And that's why everything I show you will work with Spark. In fact, a lot of examples I paste into here and get things come from Spark documentation, nothing specific to Databricks. Since we have the Azure Databricks, though, I can get access to the cloud with it for free. That's one of the benefits working at Microsoft. That's really the reason I went there. I can get free cloud resources. Why I need it, I don't know. It kind of gets back to that Atari computer, I think. So and this is going to be my only sort of marketing pitch here, but just to kind of talk about Azure Databricks, why it's so cool. So Databricks has a very similar philosophy to Microsoft in that they want things to be easy. They want to enable you to be able to do things without a lot of work, without writing tons of code. And so the idea of like GUIs and things to do it resonates really well with Microsoft. Databricks is also designed, their API is designed to run on the cloud. So they came to Microsoft and said, we'd like to have a home. So I kind of think like a puppy coming up on your doorstep. They want a home. Microsoft really wanted a first-class PaaS, SaaS kind of service for big data. So it was like a marriage made in heaven. The engineers in both companies worked for like a year together. So it's not just a matter of you just running it on VMs and stuff. It's a first-class Azure service. And frankly, it works more seamlessly in some ways than many of our native developed services. And they're separate companies, but you don't even get billed separately. So you get really easy cluster creation. And one of the things I really like in Databricks is you can have multi-user clusters. So you can share clusters, and it does this kind of preemptive interruption if somebody's hogging the cluster and let somebody else run and stuff. You get scheduling, you get notebooks, Active Directory integration and security, all these great features. And we're going to use the Databricks notebooks for our IDE when we go through the examples. So this slide is just kind of getting into the architecture. I'm going to, as a person who originally comes from sales, I'll do one little background pitch about what is going on with big data. You probably already know this, so I apologize to be redundant. But sometimes conceptually laying the groundwork doesn't hurt. But just to understand when we talk about scaling out with multiple machines, I like to use an example of picture a phone book. So you have a phone book, and you want to find anyone living on Main Street in, say, my hometown in Warwick, Rhode Island. All right, so you're going to search the phone book. Well, if one person is searching, it's going to take forever. But what if you could take it and break up the phone book by the person's last name, A's, B's, C's, and you gave a person a separate segment to work on? Well, now you've got a bunch of people working on it, and I then collect the results. Well, that could go a lot faster. Well, what if I'd scale it up even more? And I say I'm going to take a separate page and give a separate page of the phone book to each person. Well, that should go really quick. At the end of the day, I'm going to collect that result and then get my answer. So when I talk about that, those worker nodes are the people that I gave a section of the phone book to. Those are nodes, those are computers. The cluster manager would be me. I asked for this. Please do this. I partitioned the phone book, et cetera. And the driver, the Spark AI context, is really just an entry point. So in your notebook, if you're using Jupyter, for instance, you would create a context point. It's just your entry into this environment and setting that up. So just want to give that kind of background. When we talk about using R code, one of the things about it is we've changed the paradigm from taking data and bringing it to our program to process, and now we're pushing our program to the data. So we split up that data. You can picture the segments of the phone book. You have to push your program to all of those nodes. Each person has to have a copy of the instructions, and that means that it has to understand our code on those nodes. So it's not a trivial task to be able to not only split it up and do what Spark does, but you also have to be able to understand R. And kind of a little slightly different view here, but you can see that Scala and Java, those are built-in language support in SQL, but Python and R are not natively supported on Spark, but the API allows us to do that. And the primary API that you do your data wrangling and stuff with is the data frame API. So the data frame is interesting because really R has great lineage history here. They came up with the data frame. Python copied it, right? They said, that's a good idea. They took it. Spark did the same thing and said, hey, R had a great idea with the data frame. Python uses it too. Why don't we just do data frames on Spark? And because it also often leverages the SQL piece of this, it can be optimized. So data frames perform better typically than the old RDDs, the resilient distributed data sets. So I love that because, again, you're getting a win-win. You get easier to use, more native, more orthonic work, but you also get better performance. So it's really a win-win, and it's a great shift. And that's why Spark SQL also is there. So, and this is an example. You may not have known it, but yes, you can do .NET and C# on Spark. It's not really my point here as much as to show, though, there's the Java Scala API underneath the covers, and SparkR and SparkR are leveraging that. So again, they're libraries, they're packages that wrap around it, and PySpark is doing the same thing. So I know this is redundant or a little bit basic, but just to get some basic background, application program interface, what I mean when I say an API, the idea is you're exposing a service so it can be used anywhere. You want to make it so it doesn't matter what language you're using or what you're trying to do, you can just call it and use it. It provides a standard way to use a service, so you think of REST APIs, ODBC as an API, et cetera. And the nice thing is the implementation details are hidden from you. So you just say, I just need to use this. It's really become, when you get into cloud services, that's the standard now. It's like, because you don't want to have to worry about how you're getting to it. So Spark was really smart in implementing an API that exposed pretty much everything available. And so some of the things you can do with the Spark API, for instance, is you can load data. So one of the things a lot of customers asked me about Spark when I was doing that part is like, where do we store our data? How do we store it in Spark? So Spark is kind of odd. It's not a data platform. It's not meant to store data. Yes, you can persist data, but it's not like a SQL database. It's not even like requiring HDFS, although it will use HDFS. It doesn't worry about that. It's just, I kind of think of it like a massive vacuum cleaner that sucks all the data in and then pushes it all into partitions in memory on multiple computers, and then you work with it. So it really is a query engine at the end of the day, and massive query. So that's the first thing the API supports. And then once you've loaded it into your partitions, you can read, manipulate, and do your data wrangling. You can push processing out to the nodes, and that includes machine learning training if you're using that part of the API. And key thing here, too, is you might think, OK, well, now I'm all distributed processing. I don't need to use the local node. I don't need a single machine anymore. Well, actually, you do, because there's going to be times when you're going to want to use those good old open source R functions, libraries like ggplot2, and you can't do that scaled out. And I'll talk a little more about that, but the bottom line is open source doesn't scale to Spark. That's why we needed SparkR and SparkR in the first place. So you're going to want to be able to do that. And we want to retain the look and feel of the paradigm language, or the paradigm of the language. So orthonic is why I kind of say that, like Pythonic. Python does, I think, a pretty good job with this. It seems like you're actually in Python. SparkR has some really powerful things. I think you might think, I would say SparkR is a little bit more native to how R feels. Like I feel more comfortable using that. I love McGritter and to be able to pipe things, so that's one of my favorite things about it. OK, so we need some levity for a minute. So how many programmers does it take to change a light bulb? OK. That's how I feel about it. I don't do hardware. So when you talk about the idea of using the API, I like this example I found just because it shows you, in this case, the particular API is a direct library Spark kind of API. And you can see that even though you're doing it in 3 different languages, in this case, they look very similar. So this isn't even R, it's Python, Scala, and Java. And there are calls that you'll make in R that will look a lot like the same one in Python because this is a direct kind of Spark call. Other times, when you're really using data frames and things, it will look much more like R. So it's a little bit of a mix. So kind of emphasizing this, but in order to do R programming, you need to get R to the JVMs, you need to get it to the driver and to the worker nodes. And so that's a big part of the challenge in any language implementation, which is probably why R and Python are the only ones you really see out there at this point. Okay, now when I first got exposed to SparkR, and I was actually started by watching a video of this conference, I got excited when I submitted and they said, yes, we'll let you speak. I saw SparkR, and this is where it was at. Scala, Java, and Python kind of covered the entire API. SparkR was sitting back here, only covering the Spark SQL piece and kind of data frames, et cetera. However, SparkR came out, and at this point at least, it covers pretty much the whole gamut. And now SparkR covers, as far as I can tell, in researching how much, I haven't used all of this, but now it's been expanded to at least cover MLlib. I haven't seen it, good examples at least, of it supporting streaming yet in GraphX, but it does cover all the other stuff. So both of these are good. SparkR seems to have really, they move really forward. I think these packages are in competition, as we'll see. I'm kind of hoping they kind of find a way to merge and live together harmoniously, but I'll talk more about that. But I think the competition is good because it kind of puts a fire under the developers to extend it, whatever one they like. So when we talk about scaling machine learning, this is a place, again, it's also true of data wrangling. Open source machine learning libraries don't scale. This is something that a lot of people have a hard time getting away from. I had a customer that was doing this with actually a machine learning server product and was using open source libraries and said, it's not any better. I said, well, using our special, commercial RX functions, what are those? So obviously they were getting the same performance because the open source functions, they basically are limited by your computer's memory. They do not support parallel processing and certainly not multiple machines, and they're not multi-threaded. So there are ways to write code that will do that, but it's a lot of work and you have to write things to it. So that's really limited. And I did put a link down here about using deep learning models because when you talk about the MLlib and what it supports, it's not something that really gets into deep learning neural networks, but there are other ways and things you can do to kind of include those types of frameworks. So a little about SparkR versus SparkR. So SparkR was first. It was the first foray into enabling Spark. SparkR is focused on the data wrangling, mainly, I mean, the real big thing of this. How many people use like dplyr, tidyverse, all that stuff? Yeah, so really good packages. And if you like that, you probably like SparkR because it lets you use those in a really kind of natural way. Both of these libraries can be used on Spark. Now, I've seen things on Databricks site that says you can now interoperate these two. About 6 months ago, I did a presentation to the Boston R user group, though, and the day of the presentation, I crashed my cluster trying to do that. So I will say you probably can, but try it, experiment. There are different libraries. At this point in time, it automatically installed the SparkR, and then you add SparkR, and I had problems if I did it. So I actually, when I'm testing, and I never take chances, hopefully, in presentations. So I have 2 different clusters, one for SparkR and SparkR here. I think that's really true. I would do that. Yeah. All right. So just looking a little bit at what does MLlib support, this gives you a picture of what are the sort of functions, logistics, GLM, et cetera. And a lot of times it will look, expression, it will look pretty close to what you're used to seeing in R, but there's some differences there. And in SparkR, you get full dplyr support, you get data wrangling at scale, local, both of these support local data frames, and we'll see that. Good support for the MLlib, and what it does is it uses ML prefixed functions. So one of the things I would say, too, a little bit about SparkR is it seems a little more consistently implemented, less rushed, more thought out in some ways. So I do kind of like that aspect of it. The documentation is good, but to be honest, RStudio wrote it, and so there is a certain favor of RStudio to it, which is fine, but it's not so easy if I wanted to, for instance, copy out an example and paste it into a Databricks notebook because it's kind of favoring RStudio's format. And it has to be installed on Databricks. So I'll show you that. You have to install this library in order to use it on Databricks, whereas SparkR is pretty much already there, and you can just use it. And that changes a little bit, too, because originally you got a default for SparkR. Now it will ask you. You still have to bring the library in, and it will ask you that. All right, so kind of getting an overview of the SparkR API, you can see the kinds of functionality. The main areas that you get support for with these is the SQL area. You can do SQL-type functions. MLlib, we'll see on the next slide, and the data frame API. And you can also do distributed functions. So when you do, you want to call a function over the data frame and over the partitions, you can do that. And I'll show some examples of that. I think I have one more in SparkR for that. And then again, these are the implemented libraries. And I just wanted to show this because I was kind of surprised you go there and there's so many functions that are implemented in the SparkR API, and SparkR has that as well. So it's not a trivial thing. You're getting a lot of stuff there. All right, so let me kind of switch modes here. Okay, go to which place? So I'm not going to go through all this, but I started this from within Azure Databricks, and I click here, and I can go right into my Databricks cluster on my workspace. So I'm already in the workspace, and check my clusters. So here I can see the clusters are running. Again, SparkR and SparkR, and you can go in and look at the attributes. But one of the nice things I really like about this, yeah. Yep. Is that better? Great. So one of the things I like, too, is that you can set a minimum, maximum nodes. So if you want 1 to 1,000, 1 to 200, you're containing it, but it will scale automatically as your load increases, which is nice. And I've got this set to 600 minutes because I didn't want to have it stop in the middle of, I forgot to start it up. It takes about 5 minutes to restart a cluster that stopped. So let's go to the notebooks. So I borrowed a lot of the content from this from a few places, but I really like this. I think this may have been a previous year's presentation on SparkR. Again, thinking back to the original implementation, there were a lot of limitations. So this, I pulled out pieces and borrowed it heavily from this link, so I do want to credit Neil Dewar, who did this. And I put in other pieces from other places. But he had some great ideas, and of course, I took his chart as well here. But I liked it sort of what I wish I knew, because we all have that. I think Gartner calls it, we have these high aspirations, and then you hit the trough of despair. And I think that's what happened here. Like, wait, I thought this would be just like doing R. It's improved a lot, but it's evolving. So the first thing we need to do is bring in the SparkR library. And so you can see it's running Spark now. It's going to copy that library out. And I may not run all the cells individually since I have the output just to save time when I'm presenting, but you can kind of see what's going on here. Okay, while that's running, one of the things that happens, as you'll see, is, so in R, as you probably know, sometimes when you load a package that some of the functions get masked and you lose direct access to them. So you can still get to them if you use the base : and then you can reference in, so the package name : and then what you want to do. Okay, I thought it was going to show us more there is what it masked, but okay. Okay, so one of the things that I want to stop, I found, and this was a recommendation in this particular blog, was it can get confusing because when you create data frames, you can create data frames which are strictly local. They're just on the head node, and you're working there just as if you're on your own machine. And like your own machine, if you load up that head node too much, you'll crash it. I've done it, not fun. So that's one thing to be aware of, but there are good uses for having that local data frame. You want to be able to use a lot of the open source libraries. So what do? So one of the things recommended is prefix your data frame so you can kind of tell which type it is. You can check it in code, but it's kind of nice to be able to tell, okay, that's an R data frame or that's a Spark data frame. So that's one of the keys here. What we have here, I'm creating an R data frame using the standard R library data frame and just the basic stuff, so columns. And you can see right off the bat, it's a little different, right? We're creating this create data frame function. That's a SparkR function. And I'm going to convert the RDF local data frame to a Spark data frame. And notice we also have this with column. So this with column is actually the data frames, Spark data frames are immutable because they're spread out over a cluster and you can't just say make a change because now you might have 1,000 machines that have to make that adjustment. So typically what happens is instead, when I do with column, it returns a new data frame. So as I run this, what you'll notice is when you run str, a couple of good things here. One is it tells you that that's a local data frame, tells you the other one is a Spark data frame. The other thing we get from this is we can see that by doing the with column, it returned a new data frame, but since I didn't capture that in the data frame, I lost it. It just kind of returns it and gets rid of it. So if I can run that, you'll see that's what's going on. So kind of taking another look at this, but a little bit different. We'll go back to good old Iris. And I'd rather keep things simple. I thought about using all kinds of elaborate examples, but I'm trying to get the concepts across, so I'll use Iris because I think it's quick, easy, and you get the idea. So here I'm going to be creating a data frame. I'm really just converting a data frame to a data frame, but this is how I can create a data frame. This local. Here's how I would do it, again, using Spark. And I'll just create this as SDF and RDF. OK, you can see. Now, one thing I think is interesting is, notice the period disappeared. It became an underscore. So apparently, SparkR data frames do not like the period. So just be aware of that. Because actually, I was getting code errors. I'm like, why isn't this working? And I'm like, oh, I just decided to change that on me. So here we're going to do something. So here's your standard R syntax for addressing a single column, the $ syntax, right? So I want to create a new column. Very simple to do, and then I just do a calculation. And here I'm creating RDF with, basically I'm calling it a petal ratio. Not a very useful calculation, but we can see we get this petal ratio column back. That's very easy to do in open source R. When we're doing this with Spark, we have to use the with column. This time, notice I am returning it back to the data frame. So that's a big difference. And what I need to do here is passing in the name of the data frame, what I'm creating at the column name, and here's my calculation. So this is not terribly orthonic, I guess I'd say, but it works. And it's still, R syntax, not too bad, but not something you'd have to learn how to do that because it's not what you would typically do. So you couldn't just cut and paste your typical R code and just go with it. OK, now we're going to do something with filtering. So here's a trick. Not trick, really, but how you want to do things. So sometimes you want to do this heavy-duty wrangling. And you're going to do that scaled out. But maybe you want to pull it back and do a nice, box plot or ggplot2 graphic or something. You don't want to try to pull back a petabyte of data to a local cluster, a local node, because it will crash the machine. So you're going to have to subset it, do something to bring the data volume down to something that could fit. And it's not such a terrible thing, because if you have a pretty good data set and you can get a decent sample, then you can probably 1/100th of the data or less is still enough to give you the sort of visual you need and be accurate. So here I'm using the filter, and I'm doing a filter command, and again, that's PySpark. But the collect method will actually force the execution. So Spark has something called lazy execution. It won't do it unless you force it to. It's kind of like my teenager, but you have to force them to get over the couch. So it's kind of the idea there. So when you do something like collect, or we'll see something later like take, you're actually telling it, like, yeah, I know you're waiting. It just keeps building on the commands, which is nice, because obviously this could be a lot of overhead. But you want to force it back if you're trying to bring it to the head node. So here I'm bringing it and turning it into a local data frame. And I'm just taking one species in this case. And the str function is good because you can see that it is, in fact, a local data frame. You get this. So that's how you can go kind of back and forth. You can convert it from a local to a scaled out data frame, et cetera. So if we also, another way we can do this is using the sample function. And I think I have another example here. When you want to create test data sets, test and so your training and test data sets, you want to split it. You also have to change the way you do that, and I'm going to show you an example of that. But one of the things here, again, you want to, in this case, I'm doing a collect to bring it back. And the sample algorithm will allow me to pull back just a 10% in this case. So I'm creating the RDF iris sample. And then you can see here, I can do an str on the sample. And if I print it, it should just print it out. And so I've now got a local data frame in there. OK, so and one of the things I can do here is I can take that R data frame and push it through, and I can do things like box plots and stuff. So I want to do local analysis. So that's a local data frame. We can use also select in this case, which will just return a subset of columns. And again, that's a PySpark thing, so we can do that. And the collect is really handy because it'll bring it back to the head node. And a little trick here too, if I just type in the name of a data frame as I would normally say in RStudio, it displays the data frame. But if I do that with a Spark data frame, it just tells me like the description, the structure of that data frame. So it's a little different. Again, these things are nuances that it takes a little getting used to. One really cool thing though is you can use the display, and display will take the Spark data frame and it will display it, and you can do things like sorting, and you can also go into like the visualization aspect like this. So you can do all that, and this is a Spark data frame. So one of the really handy things about this, where Databricks is kind of adding a nice benefit, is I don't have to bring it back, but I can do visuals and stuff. So I can change this and say, yeah, that might make a nice bar chart. So I can switch it around, and I can go into plot options and move things around and do all kinds of stuff. So that's a really handy thing, because I don't have to keep simplifying things. And you can see here I can use the arrange to sort and do average and all these things. So I can bring all this together. And just basically do an aggregation like this, and then use display to show it back, that kind of thing. So I'm going to try to wrap up quick, because this is shorter time than I was hoping, but I'm almost done. But you can also, R and Python can work together. So if I do something like this, this allows me, create a replace view, allows me to temporarily create a table within Spark. So this is a SQL table. Now the nice thing about SQL tables is they can be seen from Python, from SparkR and SparkR. So it's a good touch point where you can pass data around. So here I'm creating a temporary table, and the older method for doing this was this way. And now I can describe the table just like it was a regular SQL table, because it is now. I can do SQL statements on it, but I can also take it and using the Spark SQL. Now R, it's just SQL. In this case, the Python one, PySpark is spark.sql. That's going to convert this SQL table into a Python data frame. So what I like about this is I could do some R work, push it into a table, take it from the table, push it into Python, do some more work, and I like that interoperability. So there's a bunch of different ways to do it, but I'm not aware of any way to directly go from one to the other, like Python to R and stuff. So you can do a bunch of stuff here. And there's a bunch of other stuff. This is in the code samples I put out there, so pull that down. But there's a lot of examples of different things you can do. This is more SQL stuff. But again, take a look at the random function. So this is how you would do a split. The idea of indexing a row and saying, I want row 5, well, what do you do when the row is on 1,000 nodes? So which one gets row 5? So because of that idea of indexing that way doesn't work, and you have to use methods like random split, et cetera, split data. And you can see some of these examples going on here. Okay, and then finally, I'll just do a quick look at the machine learning library. And here we're creating a model. But this is a scaled out model training using GLM, so it's one of those things that's masking over, and we can do the summary and we get the results, so we can scale out a machine learning as well. So I am getting low. I've got a few minutes before wrapping up, and then we're going to just break and come back, and this is going to continue on, which we'll go into. I have a really good example with SparkR, and then I'll switch into SparkR and talking about that. So any questions or anything? Okay, you have to go to the mic if you could. I know, it's a long walk. You're about as far away from it as you could get. The only rule is you have to ask questions I know the answer to. Okay.
There's a lot of walking for a real simple question. So how do we differentiate here with the GLM method? I mean, that looks just like, open source R. So how does it know? Is it by the data argument?
Yeah, so that's a good question. Because you've imported the SparkR, it's basically masking using the GLM. But the biggest indicator is if I were to pass in a local data frame to this and it crashes, then I know I'm doing something wrong, and vice versa if I was using the open source version and I passed in a Spark data frame. So that's one of the reasons I'm a big fan of putting a prefix on these, so the data frame kind of tells you what you're doing.
Okay, thank you.
Thank you. Yeah.
There's a lot to follow here, and I'm just wondering if, can you upload this notebook somewhere? Or,
yeah, so it's on GitHub.
Okay.
And let me go back to the slide. I put everything I do on GitHub, and I got a lot of content out there. But if you go to just github.com/bcafferky, and then under that shared, I've got a ton of stuff, and this is under Spark AI Summit. Yeah, you can take a picture. So that's it. So it has the slides as well. So if you're lonely or you just want to have fun looking at these riveting slides, can do that. 'Cause I think they are amazing slides as well, riveting stuff. All right, any other? Okay, so we'll take a break. You can come back with questions later, and I'll follow through now with the SparkR and the other pieces. Thank you.